Let us go to another operation, such operation in relations, and this time we are dealing with the Cartesian product of A and the such operation that is at B minus C being equal to the Cartesian product of A and B minus the Cartesian product of A and C. As usual, as we are dealing with ordered pairs, we are taking an arbitrary ordered pair that is A B, and that we are equating with one part of the particular relation, so that we can come up with a subset to prove to get the final proof of this particular such operation. So, beginning with the ordered pair AB, so AB is an element of set A times, or AB is an element of the Cartesian product of A and set B minus set C. Now, separating out the elements of the ordered pair, we get A is an element of set A and B is an element of set B minus set C. And as we all know that set B minus set C means that it would be containing elements of B which are not found in C. So it simply means that that's the next step, that is A is an element of set A and B is an element of set B, and B is not an element of set C. Note the point that it's not an element. So, now bringing out the common points and separating them. So we'll be going on to the next step, that A is an element of A, set A, and B is an element of set B, and A is an element of set A and B is not an element of set C. Now, that means the ordered pair AB is an element of the Cartesian products of the sets A and B, but that ordered pair would not be an element of the Cartesian products of the sets A and C. So it means that the ordered pair AB is an element of the Cartesian products of sets A and B minus the Cartesian product of the sets A and C, which simply means that A times B minus C, that's the Cartesian product of set A with set B minus set C, is a subset of set A times set B minus set A times set C. Now, working on the other side of the equal sign, so that we can get a subset to get the final proof. In order to avoid the confusion, we are looking at another ordered pair, that is xy, and naturally xy should be an element of the Cartesian product of A and B minus the Cartesian product of sets A and sets A and C. So it implies that xy, that is the ordered pair xy, is an element of A times B, and xy is not an element of A times C. No, not an element, because we are dealing with the minus sign, and that simply means that x is an element of A and y is an element of set B, and x is an element of set A and y is not an element of set C. Which of course leads to the next step, that x is an element of A and y is an element of B, but y is not an element of C, which simply means that x is an element of set A and y is an element of set B minus set C. Which means that if you look at the ordered pair, that is xy is an element of the Cartesian product of A and the operation set B minus set C. That is the Cartesian products of sets A and B minus the Cartesian product of sets A and C is a subset of the Cartesian product of set A with the operation set B minus set C. Now, as 1 and 2 are actually the reverse subsets, in the sense that A being a subset of B and B being a subset of A, will lead to equal sets. So it simply means that A times B minus C, that's the Cartesian product of A with the operation set B minus set C is equal to Cartesian product of the sets A and B minus the Cartesian product of the sets A and C. Thank you.